So routers are network devices that work with layer 3 packets. And packets are carrying data from network A to network B with the help of IP addresses. An IP address is a logical user configurable address, and an IP address should be unique in one network. And routers are used for developing logical layer 3 communication between the devices in the same network and between the devices in the different networks using routing. So here we can see how an IP address looks like. And an IP address is have three parts. It would have the network part, which indicates the network, the host part, which indicates uniquely a host in a network, and the subnet mask, which separate network part and the host part. So let's check out our IP address here. It have a mask of /24, which means that first 3 octets, 8 plus 8 plus 8, will equals to 24, will indicate the network address. And the network address is 192.168.1. And the rest 8 bytes will indicate the host part. And with /24 mask, we can have 254 hosts. As we can see, the 8 bytes in the IP address have different values. So starting from right to left, their value increases. So this byte 32 will have value of 1, byte 31 will have value of 2, and so on, moving to 128. When you multiply all of these numbers, you will get 255. We can see here the hexadecimal representation of 192, of 168, and for 1 here. And for 176, we can easily calculate by listing the bytes values, and then when we activate 1 byte, we can multiply them. We can multiply the activated bytes to receive the desired host address. So in this case, it's 128 plus 32 plus 16 will be equal to 176. The network address is identified when all host bytes are 0. So any byte here will have a value of 0. In our case, the network, as I said, is 192.168.1.0. And also an important part is the broadcast address, is when all host bytes are equal to 1. So in this case, the broadcast address will be 192.168.1.255. We can have another example here, and I took a more complicated IP address, let's say. It's 132.45.28.222/28. So as discussed in the previous slide, the /28 is saying that the first 28 bytes in the network address, as I said in the previous slide, that the first 28 bytes in an IP address represents the network address, and the rest 4 bytes will represent the host's range. So this can be easily calculated by adding 2 at the power of 4. The 4 is the number of bytes available from 32, so 32 minus 28 equals 4 bytes, and 2 at the power of 4 minus 2 will equal 14 hosts. So in this network, we can have 14 hosts. In fact, there are 16 addresses in total, but we should also deduct the network address and the broadcast address. Okay, so let's figure out the network address. So here we have the last 8 bytes of the IP address. And why the last 8 bytes? It is because the last 8 bytes are the only variable in this IP address. Since we have a mask of 28, we know that from the last octet, the first 4 bytes will be frozen, and the last 4 bytes will be dynamic, let's say. So in order to figure out the network address, we'll start activating the bytes here in order to figure out a number which is smaller than 222. So if we add 122 and 64, we'll get 192. But if we'll add also 32, we'll get the number 223, which is bigger than 222. So which means this byte cannot be activated. But if we will activate 16 and we'll add 128 plus 64 plus 16, we will receive 208, which means that this is our network address. And keep in mind that in the previous slide I explained that in order to figure out the network address, all the host's bytes should be deactivated or 0. So now let's calculate the host's range. So the first host will have the last byte activated, and we'll get that the first address in the range is 209. It's basically easier to do if you add 208 plus 1 and 208 plus 2. And as you can see, the 2 here is represented here by activating this byte. It's also the same for 4, activating this byte. 5, you'll activate this one and this one. 7, you activate all of these 3 bytes, and so on till you reach the broadcast address. And as I told you, the broadcast address is all ones, and our broadcast address will be 223, and our host in this range will be the last address in the host range. How does an IP packet look like? An IP packet can have multiple fields. The most important ones are version, protocol, source IP, destination IP, and data. The version is showing us which protocol we are running, IPv6 or IPv4. The source IP indicates the point of the origin of an IP packet, or it is basically the sender's address. Destination IP indicates the destination address or the address of the receiver. Protocol will indicate the type of the protocol, and the data field is the actual data that is being transported by the packet. Also, it is important to know that we can have an option for the interface, which is the maximum transmission unit. MTU is described as the maximum packet size to be sent over an interface without being fragmented. So let's say that we have a packet with MTU of 1500 bytes, and the interface MTU is 1514 bytes. In this case, the packet will flow without being fragmented. But if we would have a packet with MTU of 9126 bytes, and the interface MTU is 1514 bytes, the packet will be fragmented in this way: 9126 divided by 1514, and we will receive a value of 6.02 packets. So this means that instead of one packet, device will fragment and generate 6 new packets. The MTU will have to be adjusted on either of the sides depending on physical interface capabilities. And from my experience, when having different MTU on both sides, the connection will not work properly, especially the TCP or UDP connection. The ping might work. But if you want to access a web page and the devices have a different MTU, it will not go up. And depending on the interface, we can have a bigger value of MTU or a smaller value of MTU.